Spring, 1943. Somewhere in the American Midwest, a train longer than most men had ever seen rolled slowly through countryside that had never known war. Flat car after flat car stretched toward the horizon, each one carrying something that would have made Axis intelligence officers go pale. 40mm Bofors anti-aircraft guns. Not a dozen, not 100. Thousands. Row after row of gleaming steel barrels, their twin mounts still smelling of factory oil, wrapped partially in canvas against the elements, headed toward ports where ships waited to carry them across oceans to sailors and soldiers who would point them at the sky and pull triggers that would erase enemy aircraft from existence. In a factory in Detroit, another shift ended. Workers streamed out past the gates, lunch pails in hand, faces showing the exhaustion of 12-hour days building weapons instead of automobiles. Behind them, the assembly lines never stopped. The night shift was already taking positions, already resuming the mechanical ballet of production that turned raw steel into instruments of death. Every 8 hours, 24 Bofors guns rolled off that single factory's line. Every day, 72. Every month, over 2,000. And Detroit wasn't alone. Factories in Pennsylvania, Ohio, California, and a dozen other states were doing the same, flooding the world with anti-aircraft guns at rates that defied comprehension. Across the Atlantic and Pacific, Axis commanders were beginning to understand what those production numbers meant. In Berlin, Luftwaffe intelligence officers compiled reports from pilots who had attacked American convoys and invasion fleets. The reports shared a common theme: overwhelming defensive fire, walls of tracer rounds reaching into the sky, aircraft disintegrating before they could release weapons. Missions that should have succeeded turned into massacres where half the attacking force never returned. In Tokyo, similar reports arrived from kamikaze bases. Pilots who should have struck carriers were being cut down hundreds of yards from their targets. The Americans had created something the Axis couldn't counter, not superior tactics or better aircraft, but simply more guns than could be overwhelmed. The 40mm Bofors wasn't a secret weapon. Its specifications were known, its capabilities understood. What the Germans and Japanese hadn't anticipated was the scale. American industry, when fully mobilized, operated on principles that seemed to violate the natural order. Where other nations built weapons by the hundreds, America built them by the tens of thousands. Where other nations rationed ammunition, America produced it by the millions of rounds and told gunners to fire freely. The abundance was itself a weapon, psychological as much as physical. What happens when 200,000 guns stand between an empire and its target? In 1940, the Luftwaffe and the Imperial Japanese Navy Air Service were the most feared air arms in the world. Germany's Air Force had pioneered tactical air support during the Spanish Civil War, refined it during the invasion of Poland, and perfected it in France. The Blitzkrieg doctrine depended on air superiority. Stukas screamed down on enemy positions while Messerschmitt fighters swept opposition from the sky. In 6 weeks, the Luftwaffe helped Germany conquer France, a feat that had eluded them for 4 years in World War I. The message was clear: control the air, and you control the battlefield. Japan's naval aviation had developed along parallel lines, but with different emphasis. Carrier-based aircraft were the cutting edge of naval warfare, and Japan had built the finest carrier force in the world. The Mitsubishi A6M-0 fighter could outmaneuver anything the Allies fielded in 1941. Japanese naval aviators were superbly trained, many with combat experience from the war in China. When they struck Pearl Harbor in December 1941, they demonstrated what modern naval aviation could accomplish. 8 battleships sunk or damaged, multiple smaller vessels destroyed, nearly 200 aircraft obliterated on the ground, all from carrier-based aircraft in a single morning's work. For the next 2 years, both Axis air forces maintained their edge through superior training, combat experience, and tactical innovation. German pilots shot down Soviet aircraft in ratios that sometimes exceeded 10-to-1. Japanese naval aviators dominated the skies over the Pacific and Southeast Asia. The Allies suffered catastrophic losses trying to contest airspace over Europe and the Pacific. RAF Bomber Command lost thousands of aircraft over Germany. American heavy bombers flying unescorted daylight missions took horrific casualties. In the Pacific, Allied ships burned and sank under Japanese air attack. The equation seemed immutable. Axis air forces attack, Allied forces die. But that equation depended on the Allies being unable to defend themselves effectively. Early in the war, anti-aircraft defenses were primitive and ineffective. Heavy guns were too slow to track maneuvering aircraft. Light machine guns lacked the punch to bring down bombers reliably. Something was needed that bridged the gap, a weapon with enough hitting power to destroy aircraft, but fast enough to track targets moving at hundreds of miles per hour. The 40mm Bofors gun, designed in Sweden in the 1930s, was that weapon. But knowing a good weapon exists and actually fielding it in decisive numbers are very different problems. The British had adopted the Bofors before the war and used it extensively during the Battle of Britain and in North Africa. Their combat reports were unequivocal. The Bofors worked. It shot down aircraft consistently. Crews could be trained to operate it effectively in a fraction of the time required for larger guns. The rate of fire was high enough that near misses often still achieved effects through intimidation and forcing enemy pilots to break off attacks. If anything, the British wished they had more Bofors guns, many more. The problem was British industry, already strained to the breaking point, producing Spitfires, tanks, ships, and everything else a nation at war required, couldn't manufacture Bofors guns in the quantities needed. American industry faced no such constraints. When the United States entered the war in December 1941, the arsenal of democracy that Roosevelt had promised began transforming from slogan to reality. American factories that had produced automobiles, refrigerators, and farm equipment retooled for war production. The scale was staggering. General Motors, which had built cars, began building aircraft engines, guns, and tanks. Ford constructed Willow Run, a single factory building over a mile long that produced B-24 bombers at the rate of 1 per hour. Chrysler, Firestone, York Safe and Lock, companies from every industrial sector converted to war production. The Bofors gun became a priority. The U.S. Army and Navy both recognized it as critical to defending ships, bases, and ground forces from air attack. American engineers studied the Swedish design, made minor modifications for easier mass production, and created manufacturing plans that called for production in the tens of thousands. By early 1942, Bofors guns were rolling off assembly lines. By mid-1942, production had ramped to hundreds per week. By 1943, it had reached thousands per month. The numbers were beyond anything the Axis could match or counter. German intelligence officers examining captured American equipment in Tunisia and Sicily sent reports back to Berlin that bordered on the apocalyptic. A single American destroyer carried 6 to 8 Bofors mounts. American cruisers carried 20 or more. Multiply those numbers across hundreds of ships, and the defensive firepower approached the absurd. How could the Luftwaffe attack targets that could put up walls of explosive shells? The intelligence analysts did the mathematics. To overwhelm the anti-aircraft defenses of a typical American cruiser would require attacking with bomber formations larger than most Luftwaffe groups possessed. And even if such an attack succeeded, the losses would be catastrophic. The exchange ratio had shifted. The Allies could afford their losses. The Axis could not. Japanese intelligence reached similar conclusions. Reports from kamikaze pilots who survived aborted missions, a tiny fraction of those launched, described American ships wrapped in fire. The carriers and battleships they were supposed to destroy sat behind barriers of tracer rounds and explosive shells that seemed impenetrable. Some pilots claimed it was impossible to approach American ships. Others reported that aircraft were being destroyed hundreds of yards from targets, too far away for their final explosions to cause damage. The kamikaze tactic, designed to guarantee hits by removing the pilot's survival instinct from the equation, was being defeated by firepower so dense that suicidal determination wasn't enough. The strategic implications terrified both Axis powers. Air superiority, which they had taken for granted early in the war, was slipping away. Not because Allied aircraft were superior. In many cases they weren't. Not because Allied pilots were better trained. Often they weren't. But because Allied ships and ground forces were becoming too dangerous to attack. The defensive firepower, centered on the Bofors but including radar-directed heavy guns and proximity-fused shells, was creating zones where aircraft couldn't operate without accepting losses that no air force could sustain. And unlike pilots, which took months to train, the Bofors guns could be produced continuously, shipped anywhere, mounted on anything, and crewed by sailors and soldiers with minimal training. By summer 1943, American production of Bofors guns had reached levels that seemed to defy physics. Over 50,000 had been manufactured. By the end of 1943, that number exceeded 100,000. By mid-1944, it approached 150,000. Final wartime production would surpass 200,000 guns of all types, single, twin, and quad mounts for naval use, mobile and stationary mounts for ground forces, specialized versions for every imaginable application. This wasn't a weapon system. This was an industrial tsunami that armed every ship, every base, every convoy, every forward position with firepower that turned the sky into a killing zone. July 1943. Operation Husky, the invasion of Sicily. Over 2,500 Allied ships filled the waters off the southern coast of the island, carrying 160,000 troops and their equipment for the first major amphibious assault on Axis-held Europe. The Luftwaffe, operating from bases in Sicily, Sardinia, and southern Italy, could muster approximately 1,400 aircraft. For once, the Germans had local numerical superiority. They intended to use it. Luftwaffe commanders planned massive raids that would devastate the invasion fleet before the troops could get ashore. In theory, they had the aircraft and pilots to accomplish it. In practice, they were about to encounter something they hadn't prepared for. HMS Karen, a British destroyer escorting American transports in the invasion fleet, carried 6 40mm Bofors mounts, 12 barrels, 1,140 rounds per minute of combined fire. Gunner's mate Tommy Richards manned the starboard loader position, responsible for keeping ammunition clips feeding into the gun. He had trained for months. Now, with German aircraft appearing on the horizon in formations that blocked the sun, training would give way to reality. The klaxon screamed. General quarters. All hands to battle stations. Richard sprinted to his gun, heart already racing, hands already reaching for the first ammunition clip. The German formation was disciplined and professional. Junkers Ju-88 bombers at 8,000 feet, Messerschmitt Bf-109 fighters slightly lower providing escort. The bombers would drop their loads on the clustered transports. The fighters would strafe any ship that survived. It was textbook Luftwaffe doctrine, executed by veterans who had bombed London, Malta, and Murmansk. They expected losses but felt confident that some bombers would penetrate the defenses and sink enough ships to disrupt the invasion. What they encountered instead was a wall of steel that exceeded their worst nightmares. At 4,000 yards, every Bofors mount in the invasion fleet that could range the targets opened fire. Hundreds of guns, thousands of barrels, tens of thousands of explosive shells per minute reaching into the sky. The sound was beyond description, a continuous roaring thunder that made the ocean itself seem to vibrate. Tracers filled the air, every fifth round visible as a streak of fire, the invisible rounds between them just as deadly. The Germans flew into this storm of metal and high explosive expecting to emerge on the other side. Most of them never did. The first Ju-88 to die exploded at 3,500 yards, hit simultaneously by shells from 3 different ships. The bomber disintegrated in mid-air, wings separating from fuselage, bombs detonating in a fireball that briefly outshone the sun. Seconds later, 2 more bombers fell, one missing a wing, the other tumbling out of control with its cockpit shredded. The German formation tried to maintain cohesion, but pilots were human. Watching their friends die makes even the bravest hesitate. Some bombers broke formation, seeking evasive maneuvers. Others pressed on, determined to deliver their weapons. Neither group survived. Richards loaded clips with mechanical precision, his training taking over, his conscious mind retreating from the horror unfolding above him. Load clip, gunfires, load clip, gunfires. The rhythm was hypnotic, almost peaceful if you could ignore the explosions, the screaming aircraft engines, the crashes as wreckage hit the water. His gun was tracking a Ju-88 that had somehow made it through the outer defensive layers. The bomber was committed to its run now, pilot probably dead or wounded, but the aircraft still flying on momentum and determination. At 800 yards, the Bofors shells found it. The fuselage came apart like paper, fuel tanks exploding, bombs dropping harmlessly into the ocean as the wreckage tumbled past the ship. The entire German attack lasted 8 minutes. 42 Ju-88 bombers had attacked the transport area where HMS Karen operated. 31 were shot down. The 11 that survived long enough to drop bombs missed their targets, the combination of evasive maneuvers to avoid defensive fire and sheer terror making accurate bombing impossible. Not a single transport was hit. Not a single American soldier died before reaching the beach. The Bofors batteries had created a defensive zone that proved functionally impenetrable to a force that should have overwhelmed them through sheer numbers. Similar scenes played out across the invasion fleet. German fighters attempting to strafe landing craft found themselves flying into walls of 40mm fire that turned their aircraft into Swiss cheese before they could fire their own weapons. Stukas attempting dive-bombing runs were cut apart during their dives, falling in flames before reaching release points. Level bombers trying high-altitude attacks achieved nothing, their bombs scattering harmlessly in the ocean. By the end of the first day, the Luftwaffe had lost over 200 aircraft. The invasion fleet had lost 3 ships, none sunk by air attack. The mathematics of attrition warfare had shifted decisively. 6,000 miles away in the Pacific, a parallel story unfolded. April 1945. Okinawa. The largest kamikaze offensive of the war, Operation Kikusui, threw hundreds of suicide aircraft at the American invasion fleet. The kamikazes represented Japan's final aerial weapon, piloted by young men who had accepted death and sought only to take Americans with them. Their determination should have guaranteed hits. Their willingness to fly through defensive fire should have resulted in catastrophic American losses. Instead, the Bofors batteries destroyed them. USS Laffey, a destroyer on radar picket duty, endured 22 kamikaze attacks in 80 minutes. The ship's Bofors crews fired continuously, barrels glowing red from heat, crews rotating through positions as men collapsed from exhaustion. 16 kamikazes were destroyed before reaching the ship. 6 got through, their wreckage or their explosions causing catastrophic damage. But Laffey survived, held afloat by damage control and the Bofors batteries that never stopped firing even as the ship burned. The Japanese had thrown everything at her. The Bofors had made the difference between damaged and destroyed. Across the Okinawa invasion area, the pattern repeated. Kamikazes that should have struck carriers were cut down at 500 yards. Suicide aircraft diving on battleships disintegrated under Bofors fire before impact. The statistics compiled after each wave told the story. Approximately 50% of kamikazes were destroyed before reaching their targets. The other 50% either hit or near missed, but even that success rate made the tactic unsustainable. Japan was consuming pilots faster than they could be trained, achieving damage that, while significant, wasn't strategically decisive. The Bofors batteries were grinding the kamikaze corps into extinction. The gun itself operated on principles refined over decades of anti-aircraft development. Each 40mm shell was a masterpiece of precision engineering. The casing, machined to tolerances measured in thousandths of an inch, held 60 grams of high explosive. The impact fuse detonated on contact, fragmenting the casing into dozens of pieces of shrapnel, while the explosive charge added blast effect. Against aircraft constructed primarily of aluminum and fabric, the effect was devastating. A single hit could sever control cables, puncture fuel tanks, kill the pilot, or simply tear the airframe apart. The rate of fire made near misses almost as effective as hits. At 120 rounds per minute per barrel, a twin mount put 240 rounds into the sky every 60 seconds. That created a cone of fire through which attacking aircraft had to fly. Pilots reported that approaching American ships felt like flying through a solid wall. The psychological effect was profound. Even kamikaze pilots, supposedly immune to fear because they had accepted death, hesitated when confronted with the reality of Bofors fire. Training and ceremony couldn't prepare them for the actual experience of watching aircraft ahead of them disintegrate. German and Japanese pilots who survived their missions, a rapidly dwindling group as the war progressed, reported similar experiences. The Americans seemed to have unlimited ammunition. Their guns never stopped firing. Approaching any American position meant flying through fire so dense that evasion was impossible. Some pilots simply refused subsequent missions, accepting courts-martial or execution rather than fly into that hell again. Others developed combat fatigue so severe they couldn't function. The Bofors wasn't just destroying aircraft, it was destroying the morale of enemy air forces, creating psychological casualties faster than physical ones. The strategic impact of 200,000 Bofors guns rippled through every theater of World War II. In the Mediterranean, Allied invasion fleets operated with impunity, supported by anti-aircraft defenses that made Luftwaffe attacks suicidal. At Salerno in September 1943, German aircraft attempted to disrupt the American beachhead. They lost over 100 aircraft in 3 days, while sinking 1 LST. The exchange ratio was unsustainable. Luftwaffe commanders began refusing missions, telling their superiors that sending bombers against American fleets was murder, not combat. At Anzio in January 1944, the Luftwaffe tried again, committing some of its best remaining units to attacking the Allied beachhead. The result was catastrophic. American cruisers and destroyers offshore created defensive fire zones that extended miles inland. German aircraft approaching the beaches had to fly through this zone, and few survived the experience. Operation Shingle, the Anzio landing, should have been vulnerable to air attack. Instead, German air raids achieved nothing while costing aircraft the Luftwaffe couldn't replace. By D-Day, June 6, 1944, the Luftwaffe was effectively absent from the Normandy beaches. Not because they lacked aircraft, they still had several thousand fighters and bombers theoretically available, but they lacked pilots willing to fly missions that had no prospect of success. The few German aircraft that appeared over the invasion fleet were swatted from the sky by Bofors batteries and Allied fighters. The invasion proceeded with almost no interference from enemy air attack. The weapon system that had terrified Europe in 1940 had been reduced to irrelevance by 1944, in large part because American anti-aircraft defenses made air operations too costly to sustain. In the Pacific, the impact was equally decisive but more drawn out. Japan's strategy of attrition warfare depended on inflicting unacceptable losses on American forces, making the cost of advance so high that the U.S. would negotiate rather than continue. The kamikaze tactic was the ultimate expression of this strategy. Guaranteed hits in exchange for guaranteed pilot deaths. But the Bofors batteries broke the guarantee. Kamikaze success rates, which Japanese planners had optimistically estimated at 40%, turned out to be closer to 10 to 15%. The tactic still caused damage, but at an exchange ratio that favored the Americans. Japanese losses during the Okinawa campaign illustrated this brutal arithmetic. Approximately 3,800 kamikaze pilots were launched against the invasion fleet. American ships' Bofors batteries, combined with combat air patrols and other defenses, destroyed roughly 2,000 before they reached targets. Another 900 were shot down by fighters or hit by long-range anti-aircraft fire. Approximately 900 struck or near-missed ships, causing significant damage but sinking only 36 vessels out of a fleet of thousands. Japan had consumed an entire generation of aviators, achieving tactical damage that was strategically meaningless. The psychological impact on both Axis powers was profound and measurable. German and Japanese intelligence services compiled reports from survivors, from interrogated prisoners, from signal intercepts. The consistent theme was despair. American defensive firepower had become so overwhelming that attacking them was suicide. Not brave sacrifice with a chance of success, but simple suicide with no hope of accomplishing anything. This realization killed morale faster than actual combat losses. Luftwaffe pilot memoirs from late 1944 and 1945 describe a force in terminal decline. Veteran pilots refused missions or found excuses to abort. New pilots, inadequately trained due to fuel shortages and compressed training programs, died on their first or second sorties. Units that had once been elite formations became hollow shells, maintaining order structures while having almost no combat capability. The Bofors hadn't single-handedly destroyed the Luftwaffe. Fuel shortages, attrition from fighter combat, strategic bombing of airfields all contributed, but it had made attacking Allied ground and naval forces too expensive to sustain. Japanese naval aviation collapsed even more dramatically. The carrier force that had struck Pearl Harbor no longer existed. Veteran pilots were dead, killed in the attritional battles of 1942 and 1943. Their replacements had hours of flight time measured in dozens rather than hundreds, barely enough to take off and land, completely insufficient for combat operations. Sending these novices against American fleets protected by Bofors batteries was murder. Many Japanese officers knew it, but the military culture and strategic desperation prevented them from stopping. American sailors and soldiers manning the Bofors guns experienced the consequences from the other side. For them, the weapon represented survival. Every aircraft destroyed before it could deliver its weapons meant their ship didn't burn, their friends didn't die, they lived to see another day. The physical and psychological toll was severe. Standing exposed on deck, firing continuously during attacks that sometimes lasted hours, knowing that one aircraft penetrating the defenses could kill everyone nearby. This created stress that accumulated over time. But mixed with the stress was fierce pride. Bofors crews knew they were good at their jobs. They could see the results: aircraft falling in flames, ships surviving attacks that should have destroyed them, invasions succeeding because air attacks failed. The gun gave them agency, turned them from passive targets into active defenders. This psychological advantage was as important as the tactical one. Sailors who felt they could defend themselves fought better, maintained morale better, endured stress better than those who felt helpless. The logistical achievement that enabled this firepower was as impressive as the combat results. Every Bofors gun required ammunition, maintenance, replacement parts, and trained crews. American logistics provided all of it with a reliability that Axis forces found incomprehensible. Ammunition ships constantly resupplied the fleet, keeping magazines full. Repair ships fixed battle damage and performed routine maintenance. Training centers churned out gun crews who could operate the weapons effectively within weeks rather than months. The entire system worked with a mechanical efficiency that multiplied the gun's inherent effectiveness. By war's end, the Bofors had become the most ubiquitous anti-aircraft weapon in the American arsenal and one of the most successful weapon systems of the entire conflict. The production numbers told the story. Over 200,000 guns manufactured, over 400 million rounds of ammunition produced, mounting on over 10,000 ships plus countless ground installations. The weapon had appeared wherever American forces operated, creating defensive umbrellas that enemy aircraft couldn't penetrate without accepting losses that no air force could sustain. The 40mm Bofors represented the apex of a development process that had begun in the 1920s, when military theorists first recognized that aircraft would dominate future warfare. The challenge was creating weapons that could track fast-moving targets at varying altitudes while delivering enough destructive power to reliably bring down aircraft. Early anti-aircraft guns were adaptations of field artillery, large weapons firing heavy shells at high angles. They worked against slow, high-altitude bombers, but were nearly useless against faster, more maneuverable targets. The Bofors design philosophy was revolutionary. Instead of trying to build bigger guns that threw heavier shells, higher, create a medium-caliber weapon with a very high rate of fire. The 40mm shell was large enough to carry meaningful high explosive, but small enough to allow rapid-fire mechanisms. The automatic loading system, fed by 4-round clips, cycled fast enough to maintain sustained fire, while being simple enough for minimally trained crews to operate under combat stress. The result was a weapon that balanced competing requirements better than anything else available. Swedish engineers had designed the gun with manufacturing efficiency in mind. The Bofors used relatively simple machining operations, nothing that required specialized equipment or exotic materials. When American factories licensed the design, they found they could produce it using existing machine tools and skilled workers available in any industrial city. This manufacturability was critical. A weapon too complex to mass produce is strategically useless no matter how effective it is in combat. American production reached scales that dwarfed the original Swedish manufacturer's wildest projections. Bofors AB in Sweden had built hundreds of guns per year. American factories built hundreds per day. Chrysler's Bofors production line in Detroit operated 3 shifts, 24 hours daily, producing 72 guns every day at peak output. York Safe and Lock, Firestone Tire, and dozens of other companies replicated this performance. The result was a flood of weapons that armed every ship, every base, every mobile unit that needed anti-aircraft defense. The ammunition production was equally impressive. Each 40mm shell required precision manufacturing that would have been considered impossible for mass production just decades earlier. The shell casing had to be machined to exact dimensions, the explosive charge measured and loaded carefully, the fuse assembled with tolerances measured in thousandths of an inch. American factories turned this precision work into assembly line operations, producing millions of shells monthly with quality control that ensured reliable function. The versatility of the Bofors mounting systems multiplied its effectiveness. Naval versions came in single, twin, and quad configurations, allowing ships of any size to carry appropriate firepower. A small destroyer escort might carry single mounts. A battleship might carry 20 quad mounts, 80 barrels total, capable of throwing 9,600 rounds per minute into the sky. Ground versions came on wheeled carriages for mobility, or fixed mounts for base defense. Some were even mounted on modified tank chassis for self-propelled anti-aircraft vehicles. Fire control systems evolved throughout the war, progressively improving the Bofors' effectiveness. Early installations used optical sights and manual tracking, relying entirely on gunner skill. By 1943, many ships had director-controlled fire, where a central computer calculated target bearing, elevation, and lead angle, then transmitted firing solutions to individual mounts. By 1944, some installations incorporated radar ranging and proximity fuses, creating automated systems that could engage targets in darkness or through clouds. The Bofors platform proved adaptable enough to integrate these improvements without major redesign. The contrast with Axis anti-aircraft capabilities was stark. Germany fielded the 3.7mm Flak 36 and Flak 43, weapons roughly comparable to the Bofors in shell size and rate of fire. But German production never approached American scales. Total German production of all 3.7mm guns was approximately 30,000 units. The U.S. produced over 200,000 Bofors. German ships typically carried 4 to 6 3.7mm mounts. American ships carried 10 to 20 Bofors mounts. The volume of fire difference was 3 to 1 or higher in American favor. Japanese anti-aircraft weapons were even less effective. The Type 96 25mm gun was Japan's standard medium anti-aircraft weapon, but it suffered from lower rate of fire, less reliable ammunition, and significantly lower production numbers. A typical Japanese destroyer might carry 4 Type 96 mounts. An American destroyer of similar size carried 8 Bofors mounts, each with superior performance. When American and Japanese ships engaged in close combat, the American anti-aircraft advantage often proved decisive. The post-war legacy of the Bofors extended far beyond World War II. The weapon remained in service with various navies into the 21st century, a testament to how thoroughly its designers had optimized the balance of competing requirements. Modern close-in weapon systems like the Phalanx CIWS and Goalkeeper use different technologies but follow the same philosophical approach. High rate of fire combined with moderate shell size to create a defensive zone that incoming threats can't penetrate. The strategic lesson was equally enduring. Industrial capacity can be as decisive as tactical innovation. The Bofors wasn't a wonder weapon. It didn't incorporate revolutionary technology or unprecedented capabilities. It was simply a very good weapon produced in overwhelming numbers and supplied with unlimited ammunition. That combination, quality times quantity, proved devastatingly effective. The Germans and Japanese had quality aircraft and skilled pilots, but they couldn't overcome the sheer volume of defensive fire that American industry created. When World War II ended in August 1945, the Bofors 40mm gun had fired billions of rounds in anger across every theater of combat. Exact totals are impossible to calculate, but conservative estimates suggest over 2 billion individual shells were expended during the war. That's 2 billion opportunities to destroy aircraft, 2 billion explosive projectiles hurled into the sky in defense of ships, soldiers, and strategic objectives. The number is so large it becomes meaningless, too vast for human comprehension. What matters is the effect. Axis air forces that once dominated skies found themselves unable to operate where American Bofors batteries deployed. The human cost on the Axis side was staggering. Luftwaffe losses over American defended areas exceeded 15,000 aircraft during the war, many directly attributable to Bofors fire. Japanese losses were even worse. Over 20,000 aircraft destroyed, including thousands of kamikazes cut down before reaching targets. These weren't just machines. Each aircraft represented a pilot, often a crew, men who died in flames or plunged into oceans, killed by weapons that fired so fast they created walls of metal through which no one could fly. For the sailors and soldiers who manned the Bofors batteries, victory came with complex emotions. Tommy Richards, who survived the Sicily invasion and went on to serve through Salerno, Anzio, and southern France, later wrote that he never got used to killing. Every aircraft he helped destroy was another human being dying, often visible through the gun sight in the final seconds before impact. The professionalism of his job required suppressing empathy, treating enemy aircraft as targets rather than as young men terrified and desperate. But quiet moments brought the recognition that he had participated in industrial-scale killing, enabled by weapons too effective for their own moral comfort. The Axis perspective emerged slowly through post-war testimonies and recovered documents. Luftwaffe, General Adolf Galland, one of Germany's most successful fighter aces, wrote in his memoirs that American anti-aircraft fire had become so intense by 1944 that he considered ground attack missions to be suicide assignments. Pilots volunteering for such missions knew they had minimal chance of survival. The Bofors specifically was mentioned in numerous German after-action reports as creating impassable fire zones. Japanese records show similar conclusions. Admiral Ugaki, who commanded kamikaze operations, noted in his diary that American defensive fire exceeded all predictions, making the suicide tactic far less effective than hoped. the strategic implications extended beyond immediate combat results. The Bofors demonstrated that defense could dominate offense if the defending side possessed sufficient industrial capacity. Germany and Japan had built their military strategies around offensive air power, believing that bombers and fighters could break enemy resistance. The Bofors broke that assumption, proved that ships and ground forces could defend themselves effectively if armed with the right weapons in sufficient numbers. This realization influenced post-war military planning on all sides, leading to continued emphasis on anti-aircraft systems and the development of surface-to-air missiles as the logical evolution of the Bofors concept. The production achievement stands as one of the great industrial accomplishments of the war. 200,000 guns, produced in under 4 years, distributed globally, maintained in combat, supplied with ammunition despite logistical challenges that would have broken lesser industrial systems. American factories that had been building consumer goods in 1940 were churning out weapons by the thousands in 1943. The transition required retooling millions of dollars of equipment, retraining hundreds of thousands of workers, reorganizing supply chains, and maintaining quality control despite unprecedented production rates. That it worked at all was remarkable. That it worked efficiently enough to flood the world with Bofors guns was an achievement that enemies couldn't match and allies struggled to comprehend. The mathematical reality was inescapable. Multiply 200,000 guns by 120 rounds per minute, and the theoretical rate of fire becomes 24 million rounds per minute. Obviously, not all guns fired simultaneously, but even a fraction of that firepower created defensive fire that seemed insurmountable. Axis pilots who faced it described the experience as flying into solid walls of steel. Some simply refused to believe the numbers, convinced that reports of American gun density were exaggerated. But the evidence accumulated in destroyed aircraft, failed missions, and declining success rates that made air attack increasingly futile. Would you have stood behind a Bofors gun, hands loading clips as fast as exhaustion allowed, watching aircraft dive toward your position, knowing your accuracy was all that separated survival from destruction? Would you have maintained fire as the barrels glowed red, as fragments rained down, as the sky filled with tracers and explosions? The men who operated these weapons answered those questions with their actions, standing at their posts hour after hour, firing until they couldn't stand, protecting their ships and comrades with walls of steel that rewrote the rules of aerial warfare. The image of those endless rows of Bofors guns, stretching across factory lots and military depots, became a symbol of American industrial might. Each gun represented hours of labor, tons of steel, precision manufacturing multiplied across thousands of facilities. Together, they represented something more profound: the transformation of industrial capacity into strategic dominance. Germany and Japan had built empires through aggression and tactical excellence. America buried those empires under avalanches of production that no amount of skill or sacrifice could overcome. The Bofors 40mm gun was never the most glamorous weapon of World War II. It lacked the dramatic appeal of aircraft carriers, the destructive power of atomic bombs, the romance of fighter aces. It was simply a reliable, effective tool produced in overwhelming numbers and wielded by ordinary men who became extraordinary through necessity. But in its simplicity and abundance lay its power. The weapon proved that in industrial warfare, quantity has a quality all its own. 200,000 guns firing billions of rounds created a defensive system that broke the offensive capabilities of two empires and helped secure Allied victory. The legacy extends beyond military history into the realm of industrial achievement. The Bofors production program demonstrated what American manufacturing could accomplish when fully mobilized and properly organized. The lessons learned: mass production, quality control at scale, logistics management, worker training, influenced post-war American industry and helped create the economic dominance that defined the second half of the 20th century. The weapon itself may have been Swedish in origin, but the production system that flooded the world with Bofors guns was purely American. In the end, Germany and Japan didn't just face a weapon. They faced an industrial system that could produce weapons faster than they could destroy them, that could supply ammunition without limit, that could replace losses overnight, that could arm every ship and every base and every unit with firepower that made attacking them suicidal. The panic that seized Axis commanders when they learned about 200,000 Bofors guns wasn't fear of the weapon itself. It was recognition that they were fighting an enemy whose industrial capacity made victory impossible, no matter how bravely their men fought or how skillfully their commanders planned. Subscribe to WW2 Secret Archives and uncover more stories of the weapons, innovations, and industrial achievements that shaped the greatest conflict in human history. From factory floors to battlefields, from the minds of engineers to the hands of soldiers, every episode reveals how technology and production capacity decided the outcome of World War II. The next story might surprise you even more than this one.